Welcome to Bit by Bit, episode 9.2. In this episode, we're going to look at chapter 6 of assembly lines, particularly I/O using the monitor and keyboard. I've set up a little differently, so hopefully sound and stuff will work a little better this time. I got a Yeti blue microphone. Seems to be better than what's built into the webcam. But we're gonna just jump in. This is not gonna be a whole lot of setup this time. We're gonna just try to make sense of it as we go. So we're looking particularly at keys and key presses and this idea of strobing. Keys are weird. When you push them, you want them to be recognized, but you also want them to be available if you type ahead. And so these are kind of in tension. You type real fast and a whole bunch of keys go somewhere. Okay. And if you're not paying attention, you wouldn't see them. So if you're polling the keyboard, going, okay, is it pressed? Is it pressed? Is it pressed? You'd be great until it was pressed. And then while you're handling that key press, another key comes, another key comes, another key comes, and you miss a few of them. So we want to kind of figure some of that out. Although, well, we're not going to figure much of it out, but we're going to run up against how you figure out whether a key's been pressed right away. So when you press a key, if you're polling the keyboard and checking, is that key pressed? That'd be one way to do it, but that's not how we're going to do it. There's a strobe that gets set when the key gets pressed. So if the key gets pressed, the keyboard signals that it's available. And when you want to process it, you take the key and then you clear the strobe so that it knows it can go get another key or something like that. I could be mixing that up. We'll try to figure it out. Anyway, we're going to do two versions of a program, one to print the press characters, but repeating them once you pick up the key press. Like if I press P, it just prints P until I press another key and then prints that key. That's one version. And then the other one is going to print the press characters. We're going to clear the strobe between, and so it should only print each key press only once. But what's a strobe? How do we know when a key press has been made? Well, that's a good question, and I'm not sure I got answers. But I will say, I will point you at this reference, which is out there somewhere, and I'll put it in the description when I post this video. But it's inside of this reference manual. There's an Appendix B that talks about Appendix B, special locations. All right, inside of here is stuff like where the keyboard data is, where the strobe is, how to get to it, and this is a really useful document. The Apple IIe specific reference is way more detailed and it allows a lot more narrative and stuff. But this little chapter right here, Appendix B Special Locations, in the original, or at least this 1979 version, is actually super clear. And it's got a table for keyboard locations. C00, which is 49,152 decimal, or if you were going negative, it would be negative 16,384. And then CO10, which is the clear keyboard strobe. And then some other interesting addresses are also displayed in here. I wanted to point that out. That's called Appendix B, Special Locations. With that said, let's just get in and start doing the coding. Where is the book? There it is. Okay. So this is what we're going to type in. This is the first part, and then this is the second part. We'll run this and see what happens. And we'll go ahead. I'll type it in with you. So I'll stop doing that completely here in maybe another episode or two, but for right now, it's sometimes I can help, and I don't always do it, so it's not even that boring. So without further ado, let's go. We're on drive 1. I've got the Merlin work disk on drive 2. It's my Merlin work 2, so I want to change to that drive, so I hit D, and then we type edit, edit, and then we type A to add, because we haven't typed any of this yet. And let's just start typing. We remember Alt 8 is for the full line of asterisk, so Alt and 8, and then character parent, and then Alt 9 gives us the box. Tab gets us out of insert mode. We'll call it keyboard 1. All right, and then Alt 9 for another row of key. Those we're gonna skip the org thing for nowadays, and we're just gonna type the so we're gonna skip the obj version, and we're going to go with org $300, right? And then we're not going to put asterisks for blank lines. We'll just put blank lines. And then we've got some vectors. Vectors is another way to say for addresses, but these are like the keyboard vectors, if you will, and or we could think of them as firmware vectors, monitor vectors. They're just addresses where interesting functions in the monitor lie. And so we have one for the keyboard, and it's setting out at $C00, $C00. Wow, 4 zeros. It can't be that hard. That's 5 zeros. That's crazy. All right, we get rid of one. Okay, and then we have strobe, which the strobe is at C010, C010. And then finally, we have our friendly, well-known now to us, cout, character out routine, and FDED. And we're going to type our program, really. So we'll skip another line. We've got 3 defined entry points into the monitor. We have our starting location where we're going to put our bytes. This program, when it's assembled, we're going to put it over here at 300 and run it from there, which is 768 in what is it, basic. All right, which we could actually track that as a comment. Call 768 from basic. All right, so that keeps track of that. And then we're going to actually do some stuff. So first thing we do in our logic for the code is to call home, and that's another vector. I guess that actually should probably go up. $FC58, and then we can get rid of this extra line, Alt D. Those are all vectors into it. And then we have our actually code, which is start. And the first thing we do is clear the screen with home. And then we're going to loop. We're going to read keys forever. We load the accumulator with keyboard vector. And then we compare the value of $80. All right, what that does is that compares the key that we get back with 80. And if it's 80, then there's a key press waiting. And this is all talked about in here somewhere. Yeah, here. Instead, they add 80 to whatever the ASCII value of the key is you pressed. If a value less than 80 is at C0, means the key has not been pressed. So as soon as the key's been pressed, it's going to be at least 80. And then where's our code? There it is. Okay. And then we're going to branch clear, carry clear to loop. So if it's, and we know from the prior lesson that compare compares the accumulator with what's in memory. And if the accumulator is larger, then it's going to set the carry. All right. So BCC, which says that it's only going to set the carry if the accumulator is larger or equal to the value that it's comparing to. And so if the accumulator has an 80, then it's going to, if the accumulator, let's say the accumulator had 81 for whatever reason, okay, that would be larger than 80. Then when it does the compare, it's going to set the carry flag. And so it won't loop, okay? It won't branch to the loop. It only branches to the loop if it's less than 80, less than or equal to 80. Well, less than 80. Okay, so if it gets to this next line that we're about to type in, the JSR FDED, then, well, except for that's not what it is, it's JSR cout. Then it's got an actual valid character. And then once it's printed it out, it's going to jump back to the loop. And it's just going to do that forever. And we're going to turn off listing. All right, and I think that's good. It looks good. I'm going to Alt Q and ASM. It's going to symbol. It says there's a problem with line 6, and it's got that. I see the pound sign up there. So I think we got to do a couple carriage returns or something to get this eventually back. There we go. And then we can edit again. And so we'll just type E. And you can go down here to line 6, that looks broken to me, so we're going to get rid of that. Control D, and it looks okay to me. Alt Q, ASM. No errors this time. Nope, there's an unknown label in line 12. Well, we'll just keep editing until we figure it out. And go down until it says line 12. That's here. And it's called loop. LDA, keybait, EF. Yeah. Got an extra character there. That looks better. Okay, no errors this time. 16 bytes. Here are the bytes. We can parse it out and figure out what's going on. 20 is JSR, so jump to subroutine. What one? FC58, because they're in least significant byte, most significant byte, so FC58. And that'll call, that goes and clears the screen. And then AD, which is load the accumulator from where? From a location, from 00C0, least significant byte, most significant byte, so that's C0000, which means it's going to read from this location, which happens to be the keyboard. Okay, the vector that the keyboard puts characters into when they're typed. And then we have C9, which is compare, immediate, and it compares the value in the accumulator, whatever key it read, with 80 hex. And if it's less than 80, it's going to jump, it's going to branch on carry clear to F9, which is a negative jump. And you subtract F9 from FF, and that's like, I don't know, some number of instructions. It goes back to 303. All right, so 308 minus 5, I guess. And then we have 20, which is JSR, and it's EDFD, which is FDED. When we reverse the bytes, which is the character out routine, it prints out the character that is in the accumulator. And then 4C is a jump, unconditional, the 0303, which is in our code, 0303, which is the top of the loop. So seems like it's going to work. We're going to quit out of the editor. We're going to save the source. We're on drive 2. We save it. We're going to call it keyboard 1. And then we're going to save the object code. And it's available. We know it's available because right here it says object 310 bytes. And we go O to save, and then yes to save the keyboard 1. And now it's available to us to run. We can run it. So we're going to quit out of this. We're in basic. We're going to bload keyboard 1. And then it's available to us, but we can see that if we print peak 768. Yikes. Print peak 768 and get the correct print. Oh, print peed. Wow, that's sad. Print PEEK 768. Finally, 32, which is 20 in hex, which is JSR. So it got loaded. Yay. Let's go ahead and run it, and it'll sit there and print out whatever key press it's got until we press another one, which probably fill up screen pretty quick. So we'll see how it goes, but we're going to run it. And to run it, we're going to call 768. And when we do, I'm going to start hitting keys pretty quick so we can see something that resembles reality. So there it is. It's waiting. I hit a Q, W, E, R, T, Y, QWERTY, right? And then control break to break. So that worked, but it's going around and around in that loop really fast. And it says, did I get one? Did I get one? Did I get one? And it says, I got one when it got the Q. And as soon as it got the Q, it printed it out. And then it went back to the top of the loop and said, do I got one? Yeah, I got one. It's a Q. It's a Q. It's a Q. It's a Q. Until such time as we broke. So that's version 1 of the program. What about version 2? Let's take a look at it and see how it might be different. All right. This is the second one. Same org, same 4 calls into the monitor. Start's going to clear the screen. Loop's going to get a key. We're going to compare it with 80. We're going to branch if it's less. Otherwise, we're going to store the accumulator, the key that we pressed or whatever, into the strobe, which it doesn't really matter what you put in the strobe, or theoretically, the book claims that if you read the strobe. and the reading the strobe is actually quicker, so I'm not sure why the store strobe, but usually when people do this and we don't know why, there's some conventional reason as to why, and I have no clue. But it's possible that somebody somewhere does. And if they do, please comment and we'll know. But once it stores the strobe, stores the accumulator into the strobe, that resets the key, and so it shouldn't have one available anymore. And then we we print it out and we come back to the loop again. So we should get more of a typical press a key, print a key functionality. So I'm going to go ahead and re-enter the assembler. And then I'm going to edit, what the heck? And then I'm going to list, maybe we can just use this again. Yeah, we'll use this again. So I'm just going to edit it and we'll save it as keyboard 2. I'm going to go over here, hit tab, go out of that, keyboard 2. That's the same, well, that's the same, that's the same, that's the same, that's the same, that's the same. Then the rest, I'm going to go ahead and I just delete everything from here down. Alt D, Alt D, Alt D, Alt D, and then we'll just start here. So line 17 is where we're at. It's 15 because I didn't put all those comments in. But let's just quickly check. So I have org 300. I have the keyboard strobe character out, home, have the start, have the loop, have the comparison, have the branch carry, and now we're at strobe. Yeah, looks good. So we're going to store the accumulator into the strobe location, which is at C010. So we can break at the end of this and look at those values and see what's there and just confirm that it worked the way we thought it should. But then we jump the subroutine character out, and then we jump to the loop. Wow, I cannot type, save my life today. Jump, loop, and then we'll note anytime we have an infinite loop, if I can type loop, I'm always going to have a note there because that is definitely not good coding practice. But we got an infinite loop, it's going to loop, and then we want to turn the list off. That's what we'll do. Okay. And it looks reasonable to me. I don't see any weird characters this time around. So Alt Q ASM, it's assembling, doesn't seem to have a problem. Let's check the logic on here. So we got jump to subroutine at FC58, clears the screen, AD0000, gets a key press from the keyboard if it's available. It's available if it's greater than 80. If it's not, it's going to keep trying until it gets one. Once it gets one, it falls through. It's going to store that value, whatever it reads, into the strobe location, which is C010, which kind of resets the keyboard go get one routine. And then we have 20 with JSR, FDED, which is the character out. And finally, we jump to the loop again. Ding, 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 ding. So it looks good. It looks done. Let's save this source, but we're going to save it as keyboard 2. Keyboard 2. And then we're going to save the object code because it's available as well. And we'll just say yes. And then we're going to quit the basic. And we're going to B-load keyboard 2. And we can print peek 768 or 769 or whatever address we want, but there it is, it's 20, or it's 32 decimal, which is 20 hex, which is the JSR call to whatever the other two are. And we can look at there and not be kind of just speculating. We can peek into the memory at 769. Yeah, I remember doing this back in the day with my, model M100 TRS-80 thing, and I had no idea what peeking and poking was, but now I'm like, I totally get it. It's awesome. 88, which is, wow, that's not particularly helpful. That's one C0, I think. And then print peek, we'd have to get out the calculator to know. And we could. We'll do that in a minute here. 770 would be the next byte. Hit 252. So I don't know. Let's pull up the calculator to figure that out. Otherwise, it's going to make me nuts. All right, so there it is. We want to know what 88 is. 88 is decimal, so we'll change this to decimal, type 88, which is 58. Oh, this is the home, yeah, 58, and then 252 is the other one. FC58, which is the home routine. So first thing it does is clear the screen. Yeah, my bad. was thinking of the keyboard thing instead, but that's fine. It works. So it's there. It's waiting for us to run it. We can run it with call 768, which just enters it's like go for the monitor. I think we can just do it. Yeah, why not? Call 768. And it's going to sit there and wait for me to press a key. I'm going to press Q. It worked. W, E, R, and T, Y. Why not? Okay, so it seems to be working. I'm going to hit Control Break, and then we'll print peek at that location. Print peek, peek, peek. Wow. And then the location we're interested in. Where the heck my calculator go? Need that thing if we're going to be in BASIC. I need X, and I'm looking for the accumulator. So 45 hex is 69 decimals, so we'll peek 69. And that should give us what's in the register, 152. Oh, wow. Which 152? Okay, we go back to here, take the decimal 152, which is 98. And then we look in the book. What are the odds? Yeah, 98. We'll get back here in a minute. So close. There it is. Oh, I guess we could have done it that way. No, it's 98 hex, right? Yeah, 98 hex, which is Control X. Who knows? Maybe that's when I hit Control Break, it captured that as a key. So maybe we can't look at the keyboard stuff after the fact. Sorry about that rabbit trail. Maybe it was instructive. I don't know. But we've done both versions of how many things are open. Here we go. We've done both versions of the strobing. We did both versions of the cuts. So let's take a look at the second one again and kind of orient ourselves a little bit. So what is this strobing thing? The strobing thing, when we reset the strobe, it knows that it resets the value that will return from the keyboard polling thing. When we try to go out and get a key press, it won't have the 80 on it. And so we'll think it's not available, and it'll just keep looping here. If we were to not change, if we were to reset the strobe, then it would just keep having a value over 80 once we hit a value over 80, until we hit a value that was less than 80, which would not be possible with the keyboard. All right, so once you press a key, if we didn't have this stored in the accumulator, the strobe, which resets the key polling thing, then we would just constantly be printing out a key. And that's what this does. And that's what happened when we ran the thing. When we ran the thing, let's be loaded again just in case. We'll do keyboard 1. In this code, we didn't clear strobe. And so what happened? Well, when we called 768, nothing happened until we pressed the key. As soon as we pressed the key, though, things started getting wonky. So dot, comma, M, okay? And it just sits there and does that until we're done. All right, whereas in the second version, which we got to get back into, there we go. We're going to load. Oh, no, we don't have to go in here. We can just load keyboard 2. With this version of it, it sits there and waits, and then when we press a key, yippee-ki-yay, there it is, it just works. And no matter what we press, as long as we don't get too fast, we might be able to type ahead. I don't know for sure. But that's it for this episode. Hope this helps. I'm looking forward to learning more with you in the future. If you like the videos, please go ahead and like them. I think that helps raise the visibility a bit. So thanks.